is the chain rule. We'll be using the chain rule for this. All right. So let's get back to our workbook. Like I said earlier, when you differentiate cos x, you get negative sine x. When you differentiate sine, you get cos x. And when you differentiate tan x, you get sec squared x. So let's take note. So example one, which is I. It says sine 5x, sine 5x, sine 5x, which is the same as bracket sine x exponent 5. All right. So using the chain rule, we are using chain rule because this is a composite function. Chain rule. Right. So with the chain rule, we know that we need to represent each function by a letter. So let u equals to sine x. U should be equal to sine x, comma, then y should be equal to u exponent 5. All right. So now that we have this, we differentiate u with respect to x. Then we differentiate the y with respect to u. So du dx, du dx, du dx. With du dx, we are going to get cos x, as we said earlier, that when you differentiate sine, you get cos x. Then dy du equals to 5u exponent 4. So one may ask, why 5u exponent 4? Because in our last meetings, we made known that when you want to differentiate a term, using the first principle, you multiply the exponent or the power by the coefficient of the variable. But here, the variable u has a coefficient of 1. So 5 times 1 is 5. Then we subtract 1 from the power. So taking 1 out of 5, you are going to get 4. So dy dx, which is the final answer, or the formula for calculating for the chain rule, dy dx, is going to give us du dx times dy du. So dy du. So therefore, dy dx is going to give us cos x times 5u exponent 4. 5u exponent 4. All right. But u is what? U is equal to sine x. So we say dy dx dy dx equal to cos x times 5 bracket sin x exponent 4. So this one is multiplication. So we need to join, or we need to multiply the two terms to get one. So we say dy dx, which is the final answer. Dy dx is equal to 5 sin x 5 sin 4x cos x. This is our final answer. All right. Any question? All right. So let's proceed to the next question. So the next question says cos 4x. So cos 4x, cos 4x, cos 4x, cos 4x, which is the same as what? Bracket cos x exponent 4. So this the same as the first one we did. We are using the same rule, which is the chain rule. We use the chain rule because the function that we are working on is a composite function. So whenever you meet a composite function, the first thing that needs to come into your mind is to do what? To use the chain rule to differentiate the term. So we let u equals to cos x, cos x. Then we let y equals to my sorry. Then we let y equals to u exponent 4. All right. Now we differentiate u with respect to x. So du dx is equal to negative sine x. Yes, negative sine x, as we talked of earlier before the class. So there's it. Cos x is equal to negative sine x. All right. Then dy du will give us 4u exponent 3 root. Then the formula for chain rule says that we multiply the dy du by the du dx. So dy dx equals to, what did we get for the du dx? We had negative sine x equal to, all right, so let's write the formula first. Du dx du dx by dy du by dy du. So this will give us dy dx equals to negative sine x times 4u exponent 3. So when you multiply, but let's substitute the value for u first. So u equals to cos x. So divide the x. Please, any question? So divide the x is equal to negative sine x times 4 cos x into bracket exponent 4. So when you multiply, okay, please you can talk. Bright, Mr.
Yes,
Bright,
sir.
please you can
Please,
talk.
good evening.
Evening.
Thank you for your time. God bless
Okay.
you. Please, I want to ask, where did you get the minus u? Or
The sign, minus sign.
yeah, minus sign
All
at the
right.
top of the u.
At the top of the U, it's not minus. See,
It's
which part are you talking about? This
okay,
place?
it's three. Okay, it's three. It's not,
Yeah.
it's three. Okay, thank you.
Okay. Okay. So you have dy dx to be equal to 4 times the negative. So we get negative 4 sine x. 4 sine x cos 4x. Oh, sorry. It's cos 3 rather. Sorry. Yes. Cos 3 here. Because when we differentiated, we had 3. So cos 3x. Right. So we are done with the second question. Any question? Let's proceed to the next question. So the next question says e exponent 2x. E exponent 2x sine 3x. So this one, we are getting a different rule. E exponent 2x bracket times sine 3x. So this one, we have two functions here. Over here, we are dealing with two functions. We have the first function, which is this one. This is our first function. Then this one also is the another function we are working on. So this makes it what? Two functions. And whenever we see a term like this, or whenever we see terms like this, it means we are multiplying. So the rule that we are going to use is the product rule. All right. So we see let u equals to e2 exponent x. Yes, e2x, comma, then let's say vim. It's the same as the g of x and the f of x that we've been using. But just that for me, I prefer the u and the vim. So you might prefer the f of x and the g of x. It's the same thing. The only thing is that we are just changing letters that we are using for. So we differentiate u with respect to x. So du dx. So du dx, we are going to get 2e exponent 2x. Yes, comma. Then divide the x. Divide the x. We are going to get 3 times 3x. Oh, it should be cos. It should be cos. It should be cos here. It should be cos. 3 cos 3x. 3 cos 3x. Alright. So we now move on to the formula for product rule. We say that for product rule, dy dx is equal to dy dx is equal to then du dx. Then du dx. You see, it's not anything different from whatever we did the other time. It's the same thing. So if you didn't understand whatever we did the other day, you might be suffering now. But if you follow it patiently, by the end of the class, you are going to get it because it's the same thing and it's nothing different, just that we are working with trig ratios today. All right. So now we insert the variables. So divide x, divide the x, divide the x is equal to v. We have for v. V is sine 3x. So sine 3x, sine 3x brackets u dx is 2e exponent 2x plus u. We have u to be e to exponent x. Please let's meet us brackets. The dividend the x is 3 cos x. 3 cos 3x. Alright. So now that we have this, we just do our multiplication. So dy dx is equal to, so we get 6. 2 times 3 is 6. 2 times 3 is 6. This 2 times this 3, you are going to get 6. Because it is multiplication, the variables does not matter. Do you get it? We are going to get 6. We are going to get 6 sine x e to x plus 3 cos 3x e to x. So this is our final answer. You can go on to factorize it. Yes, you can go on to factorize since we have this and this. You can go on and factorize it. All right. So let's move on to the next question. The next question Okay, Mr. Bright, you be doing that. You're doing that. I just had a technical issue with my machine the other way around. That's why the first lecture video has not been uploaded. But hopefully, maybe by the close of this week, which is tomorrow and Sunday, you have it. So don't worry. So let's move on to the next one, which is a quotient. We are going to use the quotient rule for this because we have a fraction. This is a fraction. So we'll be using the quotient rule for it. So it says IV. Today we have a lot of examples in the box. So when we are going to solve, or if God permit us, we are going to solve all EX, then cos X, then cos X, cos X. All right. So with the cos X, we say since it is a quotient, we follow the same process we use when we are finding for quotient, or we are differentiating the terms of quotient rule. So you see, let U equals to the upper, which is EX, then we let V equals to cos X, equals to cos X. All right. So du dx, du dx, du dx is equal to EX. EX is the same